Oh yeah, nope, let's stop this. We'll just pause the things again, not again. Alright, be right back. False alarm, false alarm, it's all good. Oop, clipping. I thought I'd forgot to plug in the Ethernet, but I didn't. Or rather, it was still plugged in from last time. Right, well, not last week. Let's stop rambling and get to it. It's a tea drinking ASMR stream. Just kidding. It's, as the title suggests, we're going to do some more APL stuff today. And kind of a continuation of last time, except sort of two things. One is there's another utility that I might have mentioned on the last stream that's for reading table data from some kind of text file. That'll be the majority of this, hopefully. So that's the sort of stuff. It could be like a table ostensibly space separated, but you know, data doesn't always come in the cleanest formats, or formats that are so obviously consistent, or how you should import those using quad CSV and APL. So hopefully this will illuminate some of that, and then we'll have a useful generic utility. I'll explain more of that later, but first, before that, last time I was making this HTML tables program, and there's a bug, so that's great. And the bug is that it doesn't deal with col span things. So I thought I'd take a look at that. So, first thing I'm going to do is create a link between a namespace in the workspace and a folder. Done that. So now in the HTML tables namespace we have all the stuff from last time. And if we try to do a get all using the example here, I believe, then we get an issue. So here's our table. If we view the table, then we'll notice that you know, it's the fourth one that I cared about. The reason I was doing this, but presumably the problem's elsewhere as well. It looks all good at the top, but you get down here and you start to lose. We've lost the years are in the wrong columns and things like that. And that indeed I think is because this is a col span element, and the way that I've collected or decided which content belongs to which cell is wrong. So let's take a look and see if we can figure that out. So Control Enter, let's trace into our function. Fetching's not an issue. Even extracting the table seems to be fine, and the XML. I think the problem is in XML2 mat. So if we just get XML, if we just store this temporarily as a global, then we can use and since we're working in HTML tables, let's change into that space, and we're just doing XML2 mat on the 4th of X. Okay. Count the table datas within HTR. I think the shape finding is fine. I think it's this stuff that obtains the values that's wrong. So it's a bit of a ugly one-liner as well that's not very good. So maybe we can explain that, and in doing so, figure out what the problem is. So we've determined the shape based on the number of table row elements on line 3. That is just the number of rows. I think that should be fine, unless there's tables within tables. That's going to be a problem. Now, we've extracted the tables using regex, and that means that our elements, if we look at the depth vector, our table rows are all at depth 2, I think. So we could make this a little bit more explicit by saying the depth is 2, and our element is table row, and then we count those, and it's the same for this, but at least that should sort out, that should protect against there being tables. Oh, what's up, Jeff? Back from last time. Yep, don't know if you saw the beginning, but fixing a bug in the HTML tables thing from last time, and then I'm going to try and code another reading table data utility thing, which I'll explain after. But basically it's like a generic tabular data importer. But for now, got bugs. So one, yeah, the issue, the main issue is that when you've got elements that span multiple columns, it causes the data to enter the wrong columns in the APL workspace there, the club, the bug club. Yeah. Should be I should have titled it extermination or something, APL bug extermination. We'll see how far we get. Right, so yeah, first thing was noting that this is problematic if we have tables within tables. So we're just going to use the fact that we've used regular expression to extract just the table we're interested in. So we can assume that the table rows are all the ones at depth 2. Now I know, and that's a table T body. This is also a bad assumption, so actually maybe we should just take the first. Well, the more you protect, the worse it gets. Pick where. Yeah. That's probably more efficient to find the first one, and then use that to take the depth, and that's the table row depth. Okay, and so that means if it's not got a T, because T body's not universal, is it? When I handwrite tables, I just write table TRTH. So it must be frameworks and probably something to do with accessibility and more semantically correct HTML to have a T body tag that contains it. But yeah, we're not even going to assume 2. Magic numbers are bad. So depth of highest level TR elements, and we're going to make sure that the depth is equal to the table row depth and their table rows, and that's how we get the shape. And we align all the column comments. I should wait till the end to do that, doesn't matter. So yeah, a little bit more robust there in determining the shape of our table. And now let's go on to our bug. Yeah, so this line here I think is similarly not super robust about knowing exactly how many table data elements are within each table row. But since we basically just take the maximum and be done with it, I'm not so worried. because we're making a lot of assumptions about the HTML table data we're trying to get out that won't necessarily be true for some complicated table structures that you're allowed to have in HTML, but not. You'd have to do a lot of extra processing and even more dangerous assuming to bring that in as an APL matrix. So whatever. Just going to leave that. This might be interesting to look at though. The fact that it knows that. This is like this is a subset something. So here there's a 1 that means we start a new table row partition, and then within each of those partitions let's count the occurrences of table data. Yeah, that's fine. There's one here with 2. I'm trying to see what's the easiest way to access that thing with a 2, because this smells like it's going to be the column span thing that's causing our problem. Right, so it's, where's the 2? That's number 55. And if you look at these, then the 55th one, 55th element. So let's say we do the 50 drop E. Take a look. Drop rank 1 mix elements content attributes. Maybe we. Oh no, lots of attributes. Oh yeah. Images and stuff. This is a single table, yes, I'm not worried about that. About it being multiple tables. Worried about call span, which I should just search for really. We'll double check. There we go, there, .x. It's called that, isn't it? Don't like that. It does do it. Lots of zeros. It does exist. And easiest way okay. 0 less than, where's that? 1380 of the elements, the attributes. Yep. Now, why do I care about this? Why do I care about this? I don't think, I mean, it's good to know that it is there, but I don't think it's actually important. I think it's more just to do with recycling the elements. I don't think it's actually important that we know where the call span is and like use that for anything. There's a chance that knowing the 5 is useful, but it might be just as good, since we're computing the shape anyway. We essentially want that element. I see. Ooh. Maybe this is what we really want. What? We want to expand that set of 2 into 6. Although the zeros at the front are a little concerning. When we take our values, what I'm doing at the minute is constructing, in a fairly elaborate way, a matrix of masks. Which, if we look, let's take the first 3. Ooh. I thought. Oh, right. Okay, yeah. Yep. Interesting. There should be groups of 6 pretty early on. Oh, I'm ignoring empty content. I think that's a bad idea. Potentially. I want to ignore empty content because I want to sort of be a bit cleaner in the output, potentially be a bit more efficient. The content extracted by these but just having the correct number of rows in this matrix, in sort of the compression extraction, content extraction matrix, having the correct number of rows in this, because each row is supposed to correspond to a TR there. That should in theory be enough. However, this is the 56 rows, and if you like, see all those 6s? Can you do an inverse where on this? No. No. It's just where? And then 1 each them? I'm thinking, can I turn this list of lengths? No, because it depends on... Well, maybe. Because we know where the starts of the TRs are. It's the depth is the table row depth, and the element itself is a table row. It's called TRD, isn't it? Yeah. So this is where all of them begin. And then we just add, oh, but we don't know. Yeah, okay, you can't do it that way because we don't know the locations of those specific table data elements. So that's kind of lame. We do know that we can probably manipulate this expression a bit more. To create this mask in a maybe more efficient way. But the problem still remains that essentially once we have the values, we don't have enough values. 326, and we need 336. Essentially, we're missing 10. Which is that? 1, 2. No, because that'd be 12 if we needed to fill all of them out. Things that make you go, Other things you haven't thought about. Alright. Reset. Rethink. What are we trying to do? We have a whole bunch of content. We want to extract the content for each of these 56. Also, like I said, about having the right number of rows here. Why is that? That's a lot. A lot of indices. That's the indices of every... Oh, this. Oh, this is what's messing us up. Yeah. The indices of every element. Well, IDs of every element. But really it's our taking of the table datas. Of course there aren't enough. I do still think that shouldn't matter that much. What do you mean? Well, if you take this, which is the known number of elements per thingamabob, per number of table datas per table row, and you take this, which essentially through pure luck ignores the first two things, which if we look at the site, I'm guessing we don't care about the first. This is the fourth table, which is the 1961 here. I'll say first two rows I thought. Although now I'm less sure. Look at this table. Interesting. We do want that. Why there are two empty table rows at the beginning? Is it large, is it? Is this whole stream going to be fixing the bloody bug? Oh, well, yeah, okay, table row with no table datas in it, sure. There's table head. Table head, table head, table head. Fine with that. Here's the other one. So why TR? Here's a TR that does have table data. And we've got content, and we get the content. Maybe it's to do with, oh, because I'm catenating a thing on top. So that's a kind of a false alarm. Do you need that? I guess otherwise it's gonna always make the first one empty even if there's stuff in it. No, of course, because the first table row has no table data in it. That's the whole point. So what I'm thinking right now is something like we've more or less got the content extracted. But essentially we need to pad with empty stuff. We need to pad with empty stuff where in some places. Now, the fact that this suggests that there's only 4 missing when we know from the squareness of the shape it should be more like 10 missing elements. Loose table datas, let's think. Yeah. Well, there'd be at least 6 as not part of that. Oh, that might explain it. If we're ignoring the header, then that accounts for 6 elements. In terms of how we've computed the shape, but the fact that there's missing elements. So 1 header accounts for 6, and then the missing 4 does make 4. Now if you look at that, that's 57. That's 326, which does account for all of them. Weirdly. But we don't care about the first one because that's an artifact, I think. The second one is also the header. But if we do a 2-drop, that's assuming that we have a T head. I mean, there's so much more processing that's required to make this thing robust. Yeah, let's try it. Let's try it. So we've got these elements. Wait, this says T body, but we know there's a T head here. Wonder why that's missing. Well, actually, maybe this is the answer to the should the calls include the THs. Because we need the table heads in order to fill out correctly, and also, you know, my plan is to take this count of elements within each row and use it to create an expansion vector that fills with empty slots as necessary. So here, you know, we'd have like, it'd be all ones, 1 1 1 1 1 1 1, and then this would be 1 1 and then 4 zeros. And when you do that, or you can even do compress with negative numbers. So what's this? Yeah, AB. Okay, well that's not very good, but you do space equals, and you can see that now we filled the spaces. Or you can actually do a 1, 1, neg 4 compress AB, I think. The problem is you need more stuff. So no, I think the expansion is the way to do it. Or it's a neg 5. Oh no, because that takes away. Yeah, okay, so the expansion's the way to do it. But, you know, same difference. But this lack of table header data is going to throw us off, and it's going to be a real pain. And also, in terms of bringing this stuff in, ignoring the header content's probably not the best thing. Now the table header, oh sorry, no, this part of the shape stays the same. It's this part here where we also include now the table header elements. Aha, and there you go, that's that first thing there. And I think we want to one drop this or something, or do we even need to prepend with the zeros? This is what's confusing me. This is apple cart fast partition sum. Sum each subvector. And that's to do with 1, 0, 0, 1, 0, 0, 0. Sum each alpha enclose omega, where omega can be like 1, 3, 2, 4, 4, 4, 4, and that should be 16 and 4, 6. And this should also be that, but I'm trying to figure out why that 0 needs to be concatenated on, why I'm getting an extra. It works here. Why I get an extra 0 there? Because elements. The elements that are table rows. Is it because I start with zeros? So if I started with 0, 0, 1, that should just be the 2. Do we get 4, 2? Oh, because it's supposed to start 1, 5? It'll be to do with this. In this case, assuming that we start with a partition, we get the result we want. In this case, where the nested version will discard the first blank elements and then do the sum. This doesn't actually do what we want. Well, that's what I get for trusting Apple Cart. Is this in the wrong place? Essentially, you do the scan, and you just want to take pieces of the scan that correspond to the partitions and then do a little bit of arithmetic. And that is to say, in this case, we're trying to get, I guess, let's do this one. The 2 and then the 16. So we have those from the scan. Essentially, it'll be that's why the 1 rotate brings the first one to the end, and then that way we grab the last element, and then that's actually one of the things you need. but that doesn't work in the general case. Of course, it's probably weird to need to do this, but apparently I do need to do this. I think I could work around this by just ignoring the first, but then, like, I'm never gonna. It's never gonna have a table row as the first element, so this is always going to fail in this way. But you know, you'd rather be more robust if you can and not do working around. You'd rather just be right. So what are you going to do? One at, you know, the last one has to be the last element, so length alpha. Can you even do that? Yes. Alpha compress. So we get the 22 out. Really, you should be doing a 1, 1 drop, sadly. Is that 1, comma? No, I don't think you want that. Maybe it's the 1 rotate. Why? Because 6 minus 4 is 2, 22 minus 6 is 16. Then you do the pairwise sum. Pairwise difference. And then you get the result you want. And even for this one, where is the partition sum? Wait, it's 0, 1, 0. It's the same data. So I think we fixed it. I'll submit a request to Apple Cart. I have a quick think. Like, is there anything? Probably check this. Ah, that'll be why you want the 0 comma. Ah, balls. Now, interestingly, why do I want this? This isn't, in theory, I'm not worried about performance and speed. And if this is the behavior I want, maybe I should just encode it using the partitioned expression, but as an APL man, part of me wants to be a bit more. If I can use these old school fast APL techniques and then just have a comment that's like semicolon fast / each alpha close omega, then you'd rather be able to demonstrate the way in which I could have coded it like this and it would work, and that's fine, and then I can move on with my life. But because of the way APL works, you have this option to go in, work at a slightly different level, a different way, use a different approach, and get high performance for relatively little effort, he says, after having spent all this time. The difference is probably quite significant, especially in this case where we're doing a lot of partitioning on nested things. When you have a lot of partitions, like these nested arrays, every one of these is essentially, it's an array of pointers. And so when it has to do the sum each, it's going to do it has to go search each of these nested arrays out, chasing pointers in memory, and then do the sums of each of those, whereas this method, the hard work is all done in this scan, and a scan is a parallelizable, it is a parallel concept, and especially with a commutative operand like plus, that can be done very efficiently. And then the rest of this is just some memory, some copying, basically. Oh, and then there's this, but you're doing fewer subtractions than the sums, which in this case take the majority of the computation. So that's why you would want to do it this way, if you can be bothered, like I apparently can. But in general, if you're just looking to get stuff done and move on, then this is a lot shorter, kind of more to the point and easier to remember. Whereas I'm going through a lot of rigmarole, but that's partially because I'm creating content and trying to put this out there and show people what's possible. So, yeah, question: does this mess? If I put the 0, does this mess this up? It does. So that's arguably why you don't want this. Or rather, you just need to catenate that if getting a bit smelly now. Bit of a stinky one-liner coming up. If the first is a 1. 1, 2, 3, 4, 5, 6, 7. I mean, this is the very upper limit of what I'd comfortably stick in one line, and this has just pushed it over the edge for me and made me think, probably don't want it as one line. But maybe if I do the waterfall style comments, maybe I'll be happier. Because now you take that, you take the 1 at the beginning, you replace that with the 0, and you should get the 6 and the 16. So this is more general. And you go to GitHub, Abrad's Apple Cart. You can issue. It's a content, it's not really a bug. Fast partitioned sum could be more general. The fast partitioned sum does not return the same results as +/each alpha enclose omega if alpha does not start a partition at does not start with a 1. This can be, you know what, it's probably worth, let's take x as question mark, 1 is, and then like 10,000 Boolean thingies, y is 10,000 floats. It's the worst case. Okay. And we're going to just compare my solution, x and y. The old idiom, and finally the nested version. And let's just see how much we've butchered the performance. Probably, again, not that much, because the majority of the computation is the same. No, it makes sense that those are different. That's the whole point, is that this doesn't provide the same results, so that's why we're fixing it. As long as these two provide the same results, you can see the difference is, well, it's basically nothing. Less than 5 or 10% is within the margin of error of the runtime user command anyway. And like I said, the bulk of the computation is the sum scan and the pairwise difference. And yep, so they're both similar speed. And let's take out this and just check that they do provide the same results. Really? R1, this, R2. How many are R1 not equal to R2? Lots of places. Then take R1. Oh, it could just be because I'm using floats. It's definitely because I'm using floats. So it's just representation problem. So if we just put this as like 1E3 or whatever, yeah, just 100. And if we look at X, it doesn't start with a partition. So we look at these and just check. Yeah, just check that our, yeah. Look at that. So we're plus 100% is two times. So does that make us like 20 times? I'm so bad at converting these runtime percentages into like factor of things. But either way, 1,000% faster. Whatever that means, much faster, and it produces the same result. And our examples for that are like this, and that's different to / each alpha includes omega, and it can be rectified using this. I could just go in and change the thing myself, but anyway. Modification of the partition vector. This can be rectified with some stuff. Brilliant. APL does that. Yeah, it has to start with a 1 because we're exploiting that the 1 rotate moves it over to the side. And I guess this is another, this is really a case in point of the, this is really a case in point of the argument for APL idioms as opposed to, some kind of library of, the Apple Cart is this, library of pre-made solutions that you don't worry about what's going on under the covers, just copy and paste. Of course, in my case, it's taking me a bit more time to think about what's going on under the covers, but I'm able to analyze what the idiom is doing and see how to repair it to fit my use case while still gaining the benefits of this idiom. Right now, the idiom itself is not very idiomatic anymore, I'd say. Like the original one, look at this. It's only what, 1, 2, 3, 4, like 5 operations, which is like peak one-liner kind of territory for APL, in my opinion. You know, it's doing just enough to not be trivial, and it's not doing so much that you benefit from splitting it over multiple lines. Whereas what I needed to do to repair it, arguably, it needs some explanation of at this point. And since, this is like, while it's a utility, it's kind of an educational thing. Arguably I should put the comments in. It's like max of oh yeah, I should probably take this and stick it in there. Maybe it should be like the table rows, especially since we use this multiple times. Table datas. And we were thinking of keeping the table headers in as well. A mask of table row, mask of table or table data or table header elements. It would help if explains the algorithm, blah, 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 blah. What, the comments or something? So yeah, that's what I'm trying to do right now. So essentially, the shape concat gets the table rows. You could call it partitioned sum, and then we factor this out as a function anyway. Yeah, Apple Cart could do with that. Maybe that's a project. Maybe that's a project in and of itself. We have these little play buttons that just take you to a TIO or something. They should really. So those all need to be updated to send you to maybe to a dialog run. Dialog run's not supposed to be super public. I don't know what the status of it is, to be honest. It's publicly available, but I don't know if we're trying to avoid people hammering it as an API. But either these TIO run examples could have more of an explanation, could just include a bunch of comments explaining how it works. Apple Cart, it's been adopted as this thing, for beginners. They find it really valuable because you can search for how to do stuff. It's like one of the number one roadblocks early days learning APL is, even though you've learnt what the individual primitives do and how the syntax works and how to construct things, you still get stuck at that moment where you're like, I know what I want to do, but how do I do it? And it's not until you ask, you tend to ask an APLer, ask in the APL Farm Discord channel or in the APL Orchard chat room, and you go, how do I do this? And the APLer goes, oh, you just whip out this, construct, you do it this way. Or oftentimes it's like, well, there's a couple of ways to do it depending on what properties of the code you care about. Is it performance? Is it just doing it quickly and readably, whatever. But yeah, so for that it's really useful. But the problem is it wasn't really intended for, and it's not really a beginner friendly thing, because a large number of these are in tacit form. stuff isn't explained fully. It's not really a teaching tool. It's an idiom library. It's a quick grab it and go sort of tool. But maybe, yeah, either extending these so they have comments, or we do like a series of notebooks, or I'll just whip out some notebooks and short videos explaining these. To be fair, I've been thinking about content to make some of those YouTube shorts. So you could have like a shorts version that just does like a Deafen's Game of Life video style, just rattle off, it does this, then it does this, then it does this, and then do a slightly longer video that really goes in and explains how all the pieces fit together properly, and then accompanying that can be some text that people can read over. Oh well, yep, there's no shortage of content that would be nice to have, is there? So I think I might do that. But until then, yeah, alright, let's do this. And then I think I might have to bounce after, and I'll have to do the other utility next time, provided I fix this. So, it is it's gonna be annoying, pairwise difference. Need to adjust Y the partition vector if it starts with. So I mean that's telling just partition vector if it starts with a 1. That's not a very good comment, because that's the code tells you that. We prepend a 0 if alpha starts with a 1. That's what the code says. Why are we doing that? It's because we actually want to keep the first. Oh well, we have it here. We want to. We want to keep the first partition sum, or keep the first partition sum if alpha begins a partition at the first index. And now that we're making it a separate function, there's no real reason for it to be a one-liner. I don't know, I'll do the waterfall, or I'll try it, but these explanations might be too long. No, don't know. So, take the cumulative sum. Ooh, don't do that. Take the cumulative sum. Going to select cumulative sum at the end. Is it that? Would you call it the end of each partition? No, it's at the at the end of each partition. And then instead of pairwise difference, which is what the code says, we're going to say subtract the cumulative sum of next partition to get the sum of this partition. Yeah, and it really, although it's a one-liner, I think that's kind of okay. Like, if this was in Apple Cart, and then Apple Cart had those explanations. I think if you were using this in your code, it would be enough to say like Apple Cart fast partition sum, and maybe even a link or something. But that would be assuming that going to Apple Cart, finding the entry would then provide you with this additional commentary. So whatever, you know. Cumulative sum. Whatever, it's funny. Ha 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 ha. We'll call it. It's like what's the opposite of a partial? And I don't mean the opposite as in the whole thing. What's something that's like more than the whole thing? A partial is like, if I was going to say it's like partial sums, because that's what we want, is the partitioned sums, but what we have is too much over sums or something. The cumulative sum at the end of each partition. We call it end sum or something. The ends. Yeah, that's good. And then end sums is. Oh well, nah, I wouldn't. I'd do it like this. Ends compress the sums. Maybe that's the way. Cumulative sum. This comment. Subtract from next partition to get the sum of this partition. Alright, that's as good as I'm gonna go, yes. Cumulative sum. Okay. Yes, they should, I think. Count of TR max of TD. Oh no, sorry, it was TR partitioned sum TD, that's the whole thing. Keep the reference as a comment on the first line. Take that. Okay, maybe that's a bit nicer. That you would reference up to there. That's why the comment's doing it. That's what that is. Pretty close. Right, what's left? Probably fixing the actual. Oh. Ah, yeah, sure. We called it sums when I was intuitively writing it, so it's probably a better name. Oh yeah, but it has. Yep. XL2 hash.x, I think that's what we're doing. Yep. And yep, and it's fixed. Okay, cool. Oh, why? No. What? Oh. Ah, what? No. No, because length D and D should have the same length. they do. Our element is a TR. I've given it the wrong thing. Oh, yeah, okay. Kill. Okay. Yeah. Fine, doesn't matter. We're doing get all on the URL, which I had. I'll get it back. Listen. And apparently I overwrote hash.x. Oh, no, I didn't. I just forgot it was the fourth one. That's what I'm grabbing. One more go around the merry-go-round. Okay. Oh, why? Interesting. Alpha is TD is no. What? Back up. Split everything up. Shape D. Oh. Why? Something's gone wrong here. Doesn't make a whole lot of sense because I didn't change any of the first 3 lines of code. View, so if we look at XML, there's 11. View the 4th XML, unless I'm getting like banned from Wikipedia or something. That looks normal. Oh, because I was using a different X, I was in a different context. Yeah, I'm just, getting to the... Been at this a little while, getting a little bit stupid. But I'm on the final leg, so I'm not going to give up. Right, this shouldn't be a problem. I will clean this up a little. Yeah. Didn't need those. And now 1, 2, 3 is the longest line. So that's what those can look like. Okay. Good. Oh no. That's not right. Yeah, well. Of course. Interestingly, it doesn't work. Interesting. Well, okay, firstly. Yep. That's supposed to be inclusive simple. Okay. Oh, and come on. And that'll be why. What's that about then? Oh. Just being real stupid right now. It's fine. We're almost there. Just rattle through it. Now shape is 2 elements of 6 by 6. Very nice. Right. Now our expansions are this. So we know it's the columns. It's hard to say, is it Java 2 squad shape or end of the shape? Whatever. Minus that. 4. all become ones. No, we said the expansion waves is the way to do this. So we take the... We know we want 4 zeros there. We want 6 ones everywhere else. 1 expanded by, yeah. I know. 1, 1, neg 4, 1. Press 1. You keep the ones and you put 4 in, so that's what you want. Oh, so essentially it's partition sum. It's called row elements. The row elements, and then it's the row elements plus row elements plus row elements plus row elements subtracted from the shape like this. No, stupid. Sorry, I'm being daft here. I want these all 6s, but that neg 2 needs to become a neg 4. So you can do that shape plus yep, and then use that. No, that's not what you want. Oh, sorry. It's not. Yeah, this is the expansion vector. Because once you take those values and use it to expand, then you should have 336 elements. What am I doing? I've got it. I just want it to be cleaner than this. Don't like this inline definy thing. I'd rather do coals. I feel like you don't need to do this multiplication. Like, it feels like you should just be able to do some arithmetic. You get the neg 4s out. The problem is you want the 6s to stay the same. Right, well, this works, so... Yep. That's the... what did I call it? Row elements. Ugh. Count of row elements. row element count. Just to count these within each of that. Yep. The largest gets concatenated to the shape. This is long and complicated too, and should really be explained. Essentially, we create a mask. Still haven't figured out if this is the best way to do this. Because this should ideally, should that account for table headers? This has the same problem with the depth. But now that's become, I mean, that's going to be immediately more complicated. Basically, if I say, okay, I want the table data and the table header elements, and in order to account for a table within a table, which this frankly is just not going to handle well anyway right now, if I say in order to account for that, I'm going to just take the table rows at the depth of the first table row, then what about the table headers? Those are going to be, oh, good point. Yeah, the table headers are going to be one within that. I don't like this, but I'm going to do it. To say ditto for table headers depth. This is fine because it's going to mostly be table data things that determine this width, this number of columns. But when we get the table datas, we want, so going back up here, it's yeah. Nope. It's that. Which ain't the end of the world. Or find rank 1 naught. Yeah. And then it's the depth is table row depth. What am I doing? That's table row depth. Dingus. So that's fine. Yeah, okay. Be more robust. Maybe, okay, this is going to have to be a come back to next time. So maybe we say to do use depth to make extraction more robust, e.g. table within table, and maybe we'll get an example, like we'll make an example to do that properly. You can see this is feature creeping to heck now, so I mean I'll leave this in as a comment and maybe as an issue on the GitHub, and then it can probably end up like I'll probably actually just take it out, say to start with it supports, you know, just a plain table. You can have it accounts for stuff going across multiple columns, which is what I'm actually supposed to be fixing right now, and I've gone off on one about this partition sum. And And you know, it can be an issue, a future thing, possibly a like an option. Maybe we should, you know, this only takes one argument. We could provide options that say whatever it is. I've got tables within my tables or something. Yep. Right now that fails. This assumes, yeah, that's going to fail. So that's fine. Let's just run this down till we get our values, and then we're making our expansion vector, which we had figured out how to do. This guy and rec. Should I use a name on that? I mean, that's what I'm trying to avoid here. Call gets out the shape. Where do I? That's this anyway. Diamondize that. It's so related. Number of columns is max of the row element count. I mean, that doesn't even need a comment, does it? That's literally what the code says. And then we can concatenate on there. This does need more explanation. Compress out content for each element. It's not great. That needs more explanation, but let's not bother. This is great because now we can do an expansion vector that is 1 compressed by the row element count minus the number of columns plus the row element count times. Leave the ones which are full alone. Create expansions for the rest. Val gets val expand by gets the expansion. And then and then with any luck, column, col. What? Oh, I haven't actually done that. Okay. And then with any luck, oh, really? Bugger. No. Well, yeah, that's fine. It's more like that. Why? 56, 332. Oh, because we're grabbing content TDs, but we're ignoring the table headers. We shouldn't be doing that. Yeah, the depth thing currently doesn't really do anything, so we should have more values now. Yeah. No. No. What? Oops. That makes sense because that's essentially what we compute precisely. But our expansion's not correct. Apart from the -4, why is it so many? Should have 4 of those, yeah. And the positive ones, why is it 330? Even though that's 332. But if you do this, that's 332. You need to keep the 2. Why is there more though? 6, 6, 2, 6. Oh, let's see. 3, 3, 2, 3, 4, 2, 4. Okay. Yeah. Plus. Yeah. Supposed to be 2, 4, 2, neg 2, 4. Bum, 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 bum. That was the whole thing. Create an expansion vector. Where we do that. Oh, good lord. One, one, not one. Not, A is this. A press for some more complicated stuff. Really? Oh, sorry. Oh. 1, comma A. Press over comma. So this is, I don't know. It's rubbish, isn't it? That's A. Not that is B. 1, comma B. A, comma B. That's right. So basically, this is a flat array method for creating an expansion vector based on some condition, which is what we're trying to do. It's a bit convoluted. Ooh, and it does it before the thing. A, comma swap B. This works, but we actually want it after the 4. After the 2, sorry. We want the 0 after the 2. Which is what this should provide. 1, 1, 0, 1. Ah. Go. Ah, wow. Yeah. Is this an Apple Cart? Yeah, this one here. Expansion vector to insert new elements after each one in BV. So you do this for rec equals col. Sorry, rather where it's not. I like mine. Nah, it's pretty neat. Yeah, this is annoying. This shouldn't really be part of the. Maybe I'll do this next time or off stream or something. But this, what I'm doing right now, maybe shouldn't, and even this maybe shouldn't be part of this XML2 map function. These should be factored out as like they do something else. They're for something else. They're just utilities. We just happen to be using them in this code, but they're not a core part of the XML2 map method and algorithm. They're not that important to it. They're quite generic. So I will do that, but let's just get let's just fix the bug that I came here to fix. Good lord. To fill with extra values. It's just bad explanations too. Here's our expansion vector, and then it's basically we've got this we're using ex naught. This is horrible. Expansion 1, expansion 2. Right, and then what you do is not ex naught. It's going to get not rec not equal to col. Therefore no, that is right. Where they're not equal, compress that, col minus that. Almost there. Compute the expansion of the expansion vector, then fill that. Oh no, it's rec, isn't it? Then ex naught to expand rec. Yeah, this needs to be factored out. This is going to be disgusting, but we're going to do it anyway. Then rec. Then x naught compress. Does that even work? Then it's diff yep. We're just going to take the values that are different, use the number of columns, subtract from there. Those are the differences. We're going to put the differences at maybe we need one. Difference at naught equals expanded. Then we don't need to create multiple expansion vectors, we just have the one. That's a lie. That becomes the expansion vector. That's still x naught. And then we use that to expand. Any more for any more? Yeah, no. Bum, bum, bum. Oh. Yep, that would help. Naught dot equals 1, 2. Hey, there we go. Listen. Hope I could actually write. No. Oh yeah. One compressed by exp. One replicated by. Wow. No. 4 pick x. XML2 we're so close. Can taste it. Got the shape. Looks okay. Interesting. We've got values. And we have as many values as fills the shape, which means we don't need this taken by, and we should never need that because we're accounting for every element that we care about and that we're extracting content for now. So if there's a mismatch between the shape and the values, that's actually an error. Arguably, you should check this. Extracted TDTH values do not match computed shape. And then I don't know what error number to choose. It's not syntax. It's arguably a length error. So 5 is the. I mean, signaling an error implies a problem with the caller. Format error. Dialog format error. Anything? What does that mean? No, Stefan doesn't know about format error. He doesn't know because it doesn't. Yeah, I mean, it says what it says. But it doesn't say what it's supposed to mean. If we just search for format error. Okay. So those should be links. Oh, so that is just so. I mean, that is niche, isn't it? There's an error that only comes from Quad FMT. Sure. Okay. Limit errors more like we couldn't compute this nonce. Nah. Translation. I don't think it's internal error. It could just be exception. So let's look at translation and internal. It's not a translation error because that is to do with whether you're importing classic code into Unicode, or sorry, Unicode code into a classic interpreter, so it's not that. And the other one was it's not going to be an internal error. That's like the interpreter's messed up. Yeah. No. We're going to go with length. I'm going to go with length error, code signal 5. You know, it's as good as we'll get. Right. And then we use the shapes with the values. And we see that's not right. Oh gee, thanks. Oh, what? Yeah. No. That's what we mean. Product of the shape not equal to. Whoa. Okay. Fourth x r. We got it. Tables here. Moment of truth. Yeah. So I mean, this is what we were going for. And it's as good as you can get. So this element here spans 5 columns. So it says. So it does. 2020, yep. So this is an element, and HTML allows you to span 5 columns. APL does not allow you to span 5 columns, or rather you'd have to do some kind of, wow, is that a new, oh, it's, yep. It's a link. So anyway, it's up to the user to pass this, but the point is we get the table with the correct shape. The code is a bit more explained, it's not ideal, but it's getting better. I think, and I'm going to end this now because I've done enough. Like I'll commit this basically as is. Partition sum's a bit more explained, but I do think the partition sum should be taken out of this function. Keep the comments are fine, I think. And this stuff near the bottom, basically that whole one line where I'm compressing out content for each element should probably be factored out and explained in the same way as the partition sum is. There's a bit of still a huge open question, open debate about like style in APL. I guess I'm just going to go with my gut when it comes to that. So maybe we'll do that next stream, or maybe I'll do that off stream and just come and explain it next stream or something, I don't know. Which probably won't be for a few weeks, I don't know, a couple of weeks at least, maybe 3, yeah. Before I do this again. But yeah, all that stuff about how we extract the values arguably should be factored out, although it's a bit more relevant to the function, because the whole point is we have this XML thing and we're doing manipulations on the depth vectors and the properties, the types of elements to construct ways of extracting out the elements in the correct shape, determine what the shape is, and do the reshaping. But this stuff here is the difference, is the negation of number of extra elements to pad val. The expansion vector is actually that. Expansion vector to pad val to fill shape. Yeah, that line 16 there looks pretty dense in context compared to the rest of this. What's it called? Apple Cart. What did I do? Apple Cart expansion vector. Ugh. Not like this. Are they the same? Are they? JVI elements. Whatever. Oh, maybe this is what I want. I don't know. They just look like heavy operations compared to this. So I think I'll leave it as is. So that's Apple Cart expansion vector. And I was doing lowercase everything, which I'm not I like to capitalize the beginning of my thing so that it does imply full sentences, which these are not. Yep, to be continued, to be confirmed. I need to make some real tests soon as well. Right, so I meant to fork this, so let's, it doesn't matter. This is fixing a bug, which is in here. Fix number 2. It does, I mean, not a great GitHub commit. Not great to do this all in one thing, one big commit as well, but it's early days for this tool, so that's not so terrible, I don't think. So we're going for fix, we're going to fix number 2, that's the main thing. Explain add commentary. It's largely what we did. We thought about making stuff more robust, but I wouldn't argue that we've done that. So, and it's bad to have done this on the main branch, but it's too late now. I've already done stuff. Let's make a PR and then get out of here. So yeah, we fixed bug number 2 and we explain more code. Add commentary to explain fast partitioned sum. Dun, 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 dun. Yep. And then after this I'll also have to find out about the get issue, probably. And I also added something else here. I was supposed to, never mind. Make this a numbered list. Do that next time. Alright. Thanks very much for hanging out. Yep. Hope this was either interesting, useful, bit of both. And yeah, be a few weeks before I get to stream again or do any content, I think. Dialog user meeting coming up. I think it'll be around somewhere else. Cool.